Right now, while you're watching this video, an AI system just decided which power plant should increase output to keep your lights on. Another one is creating an entire video game world that didn't exist 5 seconds ago. And somewhere else, a synthetic human is hosting a live stream to thousands of viewers who have no idea they're watching pixels instead of a person. These aren't science fiction scenarios. They're happening today, quietly reshaping industries that have operated the same way for decades. The disruption isn't coming from flashy robots or dramatic takeovers. It's coming from software that's getting better at tasks we thought only humans could do. And the companies using these systems aren't waiting for permission to transform entire sectors.
What makes this moment different is scale. When AI can manage power grids, create entertainment, diagnose diseases, and run businesses simultaneously, the old rules about how industries work start to break down. The question isn't whether these changes will affect you, it's how quickly they'll arrive and which ones will hit first. Let's start with something that touches everyone but stays invisible until disaster strikes. Power grids across the developed world are facing a crisis. Data centers now consume about 4% of total electricity in the United States alone, and that number keeps climbing as AI workloads expand. The old system of managing electricity, where human operators made educated guesses about demand, can't keep up anymore. That's why utilities have started deploying machine learning models that forecast electricity demand every few minutes. These systems balance inputs from solar panels and wind farms, predict equipment failures before blackouts happen, and route power where it's needed most. Energy agencies report that predictive AI systems are cutting transmission losses that utilities use to accept as the cost of doing business. This isn't about building futuristic power plants. It's about software making thousands of micro decisions about where electricity flows, when batteries should store it, and how to prevent shortages before anyone notices there's a problem. The gaming industry faces a different challenge. Players demand bigger worlds, more content, and deeper experiences, but development teams can't scale infinitely. Major studios and engine developers have found a solution that changes the fundamental economics of game creation. They're using AI to generate dialogue, build environments, and control non-player character behavior in real time. Companies like NVIDIA and Ubisoft have demonstrated AI-driven characters that remember past interactions with players. These NPCs respond differently based on history, generate new dialogue instead of repeating the same lines, and create emergent gameplay moments that developers never explicitly programmed. Procedural generation has existed for years, but coherence changes everything. When AI maintains narrative consistency across hours of gameplay, the experience shifts from random content to responsive worlds. The bottleneck moves from creating assets to designing systems that guide AI creation. Some of the fastest growing social media accounts today have millions of followers and perfect posting schedules. They never sleep, never have bad days, and never age. These virtual influencers operate across Instagram, TikTok, and YouTube, attracting audiences that rival mid-tier human creators. Brands love them because they're predictable, scalable, and scandal-proof. These synthetic humans now host live streams, provide customer support, and explain products with consistency human influencers can't match. The technology behind them keeps improving, making interactions more natural and responses more contextual. What's particularly interesting is how AI analysis tools study content patterns at scale, identifying what works across thousands of channels and applying those insights instantly. Creators who understand these patterns gain massive advantages in growing their audiences. The legal industry built its entire structure around one activity that AI does exceptionally well: reading massive amounts of text. Corporate legal departments and major firms now use machine learning tools that review contracts in minutes instead of days. These systems flag risky clauses, scan millions of case documents for precedents, and identify patterns human lawyers might miss after hours of review. Recent studies show AI-assisted document review cuts analysis time by more than half, while maintaining accuracy rates that match or exceed human performance. Courts in multiple jurisdictions have started piloting AI tools to sort cases and reduce backlogs that plague the justice system. Lawyers still make final decisions, but the economics shift dramatically when software handles bulk analysis. The disruption starts with time, not expertise, fundamentally changing how legal services get priced and delivered. Manufacturing has reached a point where some factories operate in complete darkness. Not because of power failures, but because humans aren't inside them anymore. Advanced facilities, particularly in electronics and semiconductor production, use AI systems to coordinate robots, monitor quality through computer vision, and adjust production based on real-time demand data. Sensors feed continuous information streams into models that detect defects smaller than human eyes can reliably spot. These systems already operate at massive scale across Asia and are expanding globally. Humans still oversee operations and handle maintenance, but they're no longer required on the production floor. The key shift isn't just automation, it's autonomy. Production decisions happen instantly, without waiting for human approval, changing the speed and flexibility of manufacturing. Healthcare systems worldwide face physician shortages and rising demand. AI has become the pressure release valve. Machine learning systems now match or exceed human performance in analyzing medical images, triaging patients, and assessing symptoms. Hospitals use these tools to read X-rays, CT scans, and MRIs at scale, flagging high-risk cases in seconds instead of hours. Wearable devices feed continuous health data into models that detect irregular heart rhythms and other warning signs before patients feel symptoms. Doctors still make final diagnoses and treatment decisions, but AI handles the first-pass analysis that used to consume hours of physician time. The shift doesn't replace clinicians. It redirects their attention to cases that actually need human judgment, especially critical as global healthcare demands continue growing. Video production once required weeks of planning, expensive equipment, and large teams. Those constraints are dissolving. AI systems now generate realistic video from text descriptions, clone voices with proper consent, and translate speech while preserving tone and matching lip movements. Media companies and advertisers already use these tools for training videos, explainers, and localized content at scale. Recent advances focus on maintaining consistency across scenes and timing, which matters because short-form video dominates online attention. When production time drops from weeks to hours, the entire economics of content creation shifts. The disruption hits low and mid-budget productions first, where speed and volume matter more than Hollywood-level perfection. Traditional education assumes every student learns at the same pace through the same methods. AI shatters that assumption. Modern tutoring systems analyze how students answer questions, measure hesitation patterns, and identify where mistakes repeat. They adjust explanations instantly, switching examples, modifying pacing, and changing difficulty until students demonstrate mastery. Research from recent years shows AI tutoring can dramatically improve learning outcomes, especially in mathematics and science subjects. This doesn't eliminate schools or teachers. It replaces the one-size-fits-all delivery model that leaves some students behind while boring others. The transformation comes from feedback speed. Students know immediately what they don't understand instead of waiting days or weeks for graded assignments. Most people don't struggle with motivation. They drown in logistics. Personal AI systems are emerging to handle routine coordination that eats hours every week. These tools read emails, summarize what needs attention, schedule meetings, track deadlines, and execute predefined actions across multiple applications. The technology already exists, scattered across productivity software. What's new is consolidation. Instead of juggling dozens of specialized tools, users interact with one intelligent layer that understands context across their entire digital life. These systems don't make creative or emotional decisions. They handle administrative tasks that consume attention without creating visible progress. When AI manages the mundane, humans can focus on work that actually matters. Financial decisions often fail because emotions override logic. AI-driven systems remove that variable. Investment firms use machine learning to manage portfolios, rebalance assets, and optimize tax strategies based on real-time market data. These systems stress-test portfolios against historical scenarios and market shocks, making adjustments faster than human advisors can analyze the data. For individual investors, automated advisors prevent panic-driven decisions by following predefined risk rules regardless of market volatility. Assets managed by algorithmic systems continue growing globally as investors recognize the value of consistency over gut feelings. Human advisors still matter for complex situations and building trust, but routine wealth management increasingly runs on software that never sleeps and never panics. Writing code is becoming optional for creating software. AI systems now generate functional code, run tests, debug errors, and refactor existing codebases without human intervention. Developers in production environments use these tools to handle repetitive tasks, fix bugs, and translate between programming languages. Teams report dramatically faster development cycles and fewer routine errors. The key insight is that humans still design systems and make architectural decisions, but the mechanical act of typing code is shifting toward supervision. This breaks the old model where building software required hiring more programmers. When AI handles implementation details, small teams can build products that previously required dozens of developers. The constraint shifts from coding speed to system design quality. Scientific discovery traditionally moved at the pace of human insight. AI accelerates that timeline by orders of magnitude. Research teams now use machine learning to generate hypotheses, analyze datasets too large for human comprehension, and run simulations across millions of variables. These systems have identified new materials, mapped protein structures, and revealed patterns that decades of traditional research missed. The systems don't understand science in any meaningful way. They test possibilities at scales humans can't match. Researchers still validate findings and design experiments, but AI dramatically expands the search space for potential discoveries. This changes how progress happens. Breakthroughs depend less on individual genius and more on how quickly systems can explore and eliminate dead ends. Pharmaceutical development has always been slow, expensive, and failure-prone. AI attacks the earliest stages where most candidates fail. Machine learning models design molecules, predict how they'll interact with biological targets, and filter out likely failures before expensive lab testing begins. Several drugs designed primarily by AI have entered human trials, marking a fundamental shift in drug discovery. This doesn't eliminate regulation or clinical testing, which still require years of careful work. What changes is the failure rate at the beginning. When fewer dead ends reach the laboratory, development costs drop and iteration speeds increase. The pharmaceutical industry's risk profile shifts from late-stage failures to early-stage optimization. Some business tasks don't require human judgment at every step. Autonomous AI agents now monitor dashboards, manage customer support queues, run marketing experiments, update databases, and trigger complex workflows across software ecosystems. These systems observe outcomes and adjust actions without constant human prompts. Companies deploy them in operations, analytics, and internal processes where consistency matters more than creativity. The impact isn't mass unemployment overnight, it's role compression. Tasks that once required multiple people coordinating across departments get handled by a single system. The expensive layer being removed is middle management and supervision, not specialized expertise. When AI handles routine decisions, organizational structures flatten and response times accelerate. This is where all these trends converge into something unprecedented. Small businesses now use AI to analyze customer behavior, manage advertising campaigns, forecast demand, and track finances automatically. Emerging systems combine data from sales, marketing, operations, and support to recommend or execute business decisions without human intervention. These tools don't set company vision or values. They handle optimization at speeds humans can't match.
This matters because small teams historically lost to larger competitors due to slower decision making and limited resources. When software handles pricing tests, budget allocation, and operational adjustments in real time, size stops being an automatic advantage. The business structure itself transforms. Instead of hiring specialists for every function, small companies deploy AI systems that perform those roles continuously. The question becomes not how many employees you have, but how effectively you can direct AI systems toward your goals. That's it for today, folks. See you in the next video.